two things that you did in last night's video. First problem you looked at was one like this. This is one where the inequalities were already graphed for you. You had to find the maximum and the minimum. Hopefully you remember me telling you from the video, the maximum or the minimum will always occur at one of the vertex points. Does that sound familiar?
Yes.
It's not going to happen in the middle of the figure. And then you looked at a problem like this where you actually had to graph all the inequalities, and then you had to find the vertex points and plug them in. All of that is leading up to problem 16 or page 16, this fundraising problem. So with these types of problems, you will have to write the constraints. You're going to have to come up with the objective function and find the maximum or the minimum, whatever you're looking for. So this is a real type of problem or a real life problem where you have some constraints, something that's limiting you and you're trying to find a maximum or a minimum. Okay, so looking at the problem. Your class plans to raise money by selling t-shirts and caps. The plan is to buy the t-shirts for $8 and sell them for $12, and to buy the caps for $4 and sell them for $7. The planning committee estimates that you will not sell more than 120 items. Your class can afford to spend as much as $800 to buy the articles. How many caps and t-shirt sales are needed to maximize your profit? First thing you're always going to do is define your variables. Now, do we remember talking about how if you define the variables wrong, you're kind of in trouble for the rest of the problem?
Yeah.
Okay. Where do you look to figure out what the variables are? Aiden.
Question.
At the question. How many caps and t-shirt sales? So we're looking at caps and t-shirts. Can I just write X equals caps and X equals t-shirts?
Yeah.
No. What are we interested in? How many? So X is going to be the number of caps that are sold, and Y is the number of t-shirts that are sold. Next, we are going to write our objective function. If we are the person who is running this fundraiser, what is our goal? To make money, right? To make a profit. So your objective is going to be your profit. So normally we use a P. And you can see that in the problem. It says you're maximizing your profit. For every cap that is sold, so every cap, how much money are we making? For every cap that's sold, how much money do we make?
$3.
Do we make 7?
No.
No, because we had to buy them for 4. So for every cap, we make $3. So that'll be 3x. $3 for every cap. How much do we make for every t-shirt? $4. So this is our objective function. Next, we need to write our constraints. There are 2 constraints that you will always have. The first one is that x is greater than or equal to 0. The second one is that y is greater than or equal to 0. Why will you always have those?
Because you're not going to make negative.
Not profit. Aiden?
It has to be positive.
What has to be positive?
The amount.
Yeah. X being your number of caps. Can you sell a negative number of caps? Or a negative number of t-shirts? No. So these 2 you always have to include. Okay, what is one thing that is limiting us from just selling as many items as we want?
You can only sell $800.
We can only spend $800. Okay, how much do those caps cost us every time we buy a cap?
$7.
$4. So our caps cost us $4. Those t-shirts cost us $8. We cannot spend more than $800. So what is our inequality going to be? Less than or equal to. So that's one limitation placed on us. What's the other limitation placed on us? We're not going to sell more than 120 items. What does that look like as an expression? Oh, good. X plus y. So that's the number of items that we're selling. Less than or equal to 120. Anything else limiting us? No. Okay. Any questions so far? Okay, great. Let's keep moving on then. Okay, we need to graph our inequalities. So it says choose an appropriate scale and label the axes, label the vertices of the feasible region. So first thing I want us to do is label both of these axes. X is the number of caps, is that right?
Yes.
Y is the number of t-shirts. We're going to have to figure out scaling, but we can't do that yet. How would I graph those two inequalities above? Sorry, before we do that, I want to focus on these two. X is greater than or equal to 0. X equals 0 is this vertical line. Greater than 0 would mean we're shading to the right. So that'll be here. Can you guys do this with me, please? Y is greater than or equal to 0. Y equals 0 is the horizontal axis. Greater than 0 would be shading up. Okay. How would I go about graphing this top inequality? Yes, the T chart. Don't solve for Y. I've said that a lot of times. Don't solve for Y.
Oops.
If we put in a 0 for X, what do we get for Y? 100. Thank you. If we put a 0 in for Y, what do we get for X? 200. Thank you. Don't scale yet. You have to find all the intercepts before you can scale. The next one should be easy because both intercepts are 120. Now we've got to figure out the scaling. What is the highest X value we need to get up to? 200. Because we have to get to 120 and we have to get to 200. There are 20 boxes here. So what's one value I could scale by?
Go up by 20 times.
You can go up by tens. Could I go up by tens on the Y's also? What is the highest Y value I have to get to? 120. So I would definitely get there. Could I choose a different scale for Y if I wanted to?
No.
Yeah, I could. I'm going to go by tens both ways. Is that okay? Okay, so you guys start doing that. And we do realize that we should get to exactly 200, right? Not any higher or any lower.
Mm-hmm.
Okay, so let's do the top inequality. We have 200 comma 0, which is this point right here. 0 comma 100, which is this point right here. Use a straight edge. Do not freehand this. And I'll tell you why in a minute. It's going to be much harder if you freehand it. What should I do before I graph the other inequality? Figure out the shading. So let's do that real quick. If we plug in 0, we get 0 plus 0 is less than or equal to 800, which is true. So we want to shade toward the origin. When you are ready, graph the second inequality. And again, the shading is towards the origin. Okay, the feasible region is where all these shading intersects or overlaps. That would be right here. We are also asked to label the vertices of the shaded region. How many vertices are there? 4. So there's one here, one here, one here, and one here. Okay, so let's list them. We have 0, 0. We have 120, 0. We have 0, 100. And then this point here, I can't tell on my graph. Can you tell on your graph what it is?
40, 80.
Okay, Babo is suggesting it might be 40, 80. Does anyone have something that looks different? Okay, how can we check that that is in fact the right point?
Plug it in
Plug it in where?
to the equation.
Which one?
Any,
Adam?
find the slope of it and try to see if that point is on the slope of the line.
Yeah, we need to know if that point is on which line. Looking at the figure. Which line is it on? Both. So we need to verify that this point is on both of the lines, not in the shaded region, on the lines. So looking at the top equation, we have 4x plus 8y. That has to equal 800. As long as it's equal to 800, we're on the line then. So we get 160 plus 640 equals 800, which works. That is not enough. All we did was show that that point is on the red line. It also has to be on the green line, which is that bottom one. So we do 40 plus 80, again, equals 120 to show that the point is on the line. We get 120 equals 120, hence, yes, that is the correct point. For every problem like this, I need to see that work. You need to prove to me that that is the correct point. Is that clear?
Yes.
Adam?
What would, is it possible to put like no solution for one of those?
Yes. Not no solution. It's possible that this is the wrong point.
Okay.
Okay, which is a good point. What happens if this was the wrong point? If it wasn't actually 40, 80?
You have to go back.
How could we find that point? Besides just guessing and checking. Okay, well, let's write our two equations of our lines.
Do substitution.
Yes, beautiful, thank you. These are our two lines. How do we find where they intersect? Substitution or elimination? Ooh. So if this ended up being the wrong point, don't guess and check. You're going to have to solve the system then and find out what the right point is. Okay, you guys with me still? Aiden?
Just start with the substitution.
You could, sure. If you just want to start there, because you think it's easier or more efficient, go for it. We're almost done. Go to the next page. Okay, we still have to find the maximum. So it says use a table to determine your maximum profit. One side of the table, we're going to put our points. One part of the table, we are actually going to calculate the profit. So I think our points were 0, 0, 120, 0, 0, 100, and 40, 80. Can somebody verify that I copied everything right? Yeah. Is that the right objective? Okay, so now we got to plug them in. 0, 0 is going to give us 0. Bless you. This one will give us 3 times 120 plus 0. which is 360. This will give us 3 times 0 plus 4 times 100, which will give us 400. Bottom one will give us 3 times 40 plus 4 times 80. So this is 120 plus 320, which is 440. In the video, you always looked for the maximum and the minimum. Here, we don't care about the minimum profit. All we care about is the maximum. That is our maximum. Very last thing you have to do is write a sentence. So the maximum profit is $440. And when does that occur?
At 4080.
Sold 40 caps and 80 t-shirts.
Right, so at 40/80, which in the context of the problem is 40 caps and 80 t-shirts. So when 40 caps and 80 t-shirts are sold. Okay, I have a few more things to say. First one, do we have any questions? Okay, second piece. Do we understand that this is the maximum possible profit, but that they won't definitively make that much money?
Yeah.
That's only if they sell 40 caps and 80 t-shirts, but they might end up selling less than that. We get that?
Yeah.
Okay. And then